Hello, people. Just a random thought. Do you know how when you see the sun setting, it appears more orangey red and the sky appears more orangey red? Because the light is coming through extra atmosphere, and that extra atmosphere scatters a lot of the blue light out, and so what's left is the light at the redder end of the spectrum. Here's just a quick thought that just occurred to me as I was setting up my camera. When you look at the sunset, you see the sun at a more orangey red color, and the sunset sky is a more orangey red sky. And the reason for that, according to what we're told, is because the sunlight is going through extra atmosphere because of the angle at which you're seeing it. And that extra atmosphere that it has to travel through to your eye scatters more light, and blue light is the most easily scattered light. And so this is why our sky is blue, because the sunlight goes through the atmosphere and the light just bounces around and gets scattered and bounces back into your eye, and so what you're seeing is the blue light that's scattered around and into your eye. But at sunset, what you're seeing is all that blue light is actually scattered out, and all that's left is the light at the redder end of the spectrum, and that's what you see. That's why you see kind of a orangey, pinky red sky. And so here's what I find strange. When NASA shows us pictures of the Earth from space, all the clouds are white for the entire half of the Earth that's facing the camera, the satellite that's facing the ISS. So even if you look at images of the Earth from the ISS, or when they're working on the ISS and you see the Earth in the background, you see all the clouds as white. That doesn't actually make sense, because the clouds are not at the highest reaches of our atmosphere. They're actually kind of in the lower part of the atmosphere, well below the thermosphere, well below the mesosphere. So they're actually a lot of layers above the cloud layer. And so, and you know this just from flying in an airplane, you're often flying up above the cloud layer. And when you're flying in an airplane, you're only 7 miles above the Earth. So if at 7 miles above the Earth, and you're already above the clouds, then you can imagine that there's quite a lot of atmosphere between you and outer space. And so if the images of the Earth that we see from the ISS were real, then we should expect that at the very least, the edges of the Earth, all the clouds along the edges, where the light bouncing off the clouds from the sun has to go through that extra atmosphere on its way back out to the ISS, that light should be toward the red end of the spectrum. And the atmosphere above the cloud layer is obviously thinner than the atmosphere below the cloud layer. Having said that though, the cloud layer, like we just said, is quite low. And so even though the atmosphere is much thinner above the layer of clouds, there's still atmosphere there. So there's still gases, there's still molecules, there's still other things, and there's still going to be dust, interstellar dust, interplanetary dust between the ISS and the Earth. There are something like 7 tons of dust that fall into the Earth each and every day. So that would mean that there's a lot of dust falling in all around the Earth that would be in between the ISS and the clouds. So that dust, what it would do is effectively scatter out the blue light. So you should see that as the angle to the clouds is greater and there's more distance between the camera, or the eye, but the camera on the ISS, and the clouds themselves, you should see the light tending toward the red end of the spectrum. The blue light should get scattered out. And so if the images of the Earth were more authentic, then you should see a reddish tinge. Something to think about. Anyway.
Subscribe to my channel. I make a new video every now and then.